Hi everyone, welcome back to Lulumath. This video is on the difference between exponential and quadratic relations. And in order to be able to do this, you need to know what quadratic relations are. You need to understand zero exponents, and you also need to understand negative exponents. Now, exponential versus quadratic relations, these two tend to get mixed up with each other quite often. So this is something that we have to make sure that we understand the difference between the two of them. So let's organize what we know. So we have quadratic relations, we got exponential relations. For their equations, we're going to talk about just the basic equation. So the basic quadratic equation is just simply y equals x squared. This is the most basic quadratic relation, or the parent function of a quadratic relation. For an exponential relation, the most basic one is always going to be y equals some number to the power of x. So this a right here is a constant. Now, in our example that we're going to be doing here, we're going to use 2 as our a value. So we're going to do y equals 2 to the power of x. But an exponential can have any number as its base. So let's go ahead and make a table of values for this quadratic relation here. So we'll go from -3 to +3. Here, this is saying our input is -3. So if I were to take -3 and square it, I would end up getting -3 times -3, which is +9. For our next input of -2, it's going to be -2 squared, because that's what x is. X is going in as -2. And -2 squared is +4. For our next input of -1, we would do -1 squared, which is +1. This is discussed more in detail in our videos on quadratic relations. For our input of 0, it would be 0 squared, which is 0. For our input of 1, it would be 1 squared, which is 1. Notice I don't put the brackets because it's a positive number, although there's nothing wrong with having some brackets there. For our next input, it would be 2 squared. And again, brackets are totally allowed, but not necessary. And 2 squared is 4. And lastly, we've got our last input here is 3 squared, which is 9. So you can see there's going to be some sort of symmetry because we've got 9 here and 9 here, 4 here and 4 here, 1 here and 1 here. Now let's go ahead and make our chart for our example of y equals 2 to the power of x. Let's use the exact same inputs. For our input of -3 here, it's going to be 2 to the power of -3. And remember, a negative exponent means it's going to be 1 over 2 to the power of 3. And 2 to the power of 3 is 1/8. So this here is going to be 1/8. For our next input of -2, it would be 2 to the power of -2, which is 1 over 2 squared, or 1 over 2 times 2, which is 4. For our next input, it'll be 2 to the power of -1, which is 1 over 2 to the power of 1, or just simply 1/2. Now, all of these values that we got here is from understanding negative exponents. So if you need a refresher on that, go ahead and check that video out as well. For our input of 0, it would be 2 to the power of 0, and anything to the power of 0 is simply 1. Again, if you need a refresher on that, you can find that video, the zero exponents video, on the website or at the Lulumath YouTube channel. For our next one, with our input of 1, it'll be 2 to the power of 1, which is simply 2. For our next input, it would be 2 to the power of 2, which is 2 times 2, which is 4. And then our last input would be 2 to the power of 3, and 2 to the power of 3 means 2 times 2 times 2, which is 8. So as you can see, our charts are going to look very different. Let's go ahead and set up our graphs to see what's going on as well. So in our first set of coordinates, we've got an input of -3 and an output of 9. Our next one has an input of -2 and an output of 4. 1, 2, 3, 4. And I will continue doing the graph. Connect your dots. And this is our quadratic relation, and it's in the shape of a parabola. Our first point that we have here is -3 and then 1/8. So I'm going to go to the left by -3, and then I'm going to go just 1/8 of the way up. And I will zoom in here a little bit so we can get a better idea of what's going on. For our next point, it's -2 and then 1/4. So I'm going to go to the left 2 and then about 1/4 of the way up. For our next one, it's -1, 1/2. So I'm going to go to the left by 1 and then about a half of a way up. Our next one is 0, 1. Then we've got 1, 2, and then 2, 4, and then 3, 8. And if you notice the pattern, the next one would be 4, 16, which would be like way up here. So if you see, it's growing very rapidly. Now, one quick thing that people get confused about is when we cover up our left side of the y-axis and you look at the two graphs, they look to be very much the same. But here's the biggest difference. The quadratic graph is symmetrical and the exponential graph goes really, really close to some line. In this example, it's going really close to the x-axis or the line y equals 0, but never touches it. So that's something called an asymptote, which we'll talk about in depth with later videos. However, you need to see the full graph to really be able to identify whether it's quadratic versus exponential. That's it for this video. If you have any questions, let us know in the comments below or at lulumath.com, where you can also find blank or completed notes for this video. If you found this video to be useful, please make sure to subscribe and share with others. Thank you, and we'll catch you next time. Bye.